Good morning to all. Myself Vishnu Priya, currently working as an assistant professor in Department of ECE at SNS College of Technology. Today we discussed about the topic is DC circuits. So what are the key components of DC circuits? That is the conductor, resistors, inductor and capacitors. So in this topic we discussed about what are the conductors, resistors, what are the energy storage devices. So conductor is nothing but it is the current allow to flow the current flow of current allows to the circuits, and examples, there is a copper, aluminum, it is the best materials for the conductors. And what is resistors? It is the opposes the flow of current in the circuit. The unit of resistance is ohm, and it controls the current and voltage. So for example, LED, limiting and voltage dividers. So what are the energy storage devices? That is the inductor. It stores the energy in magnetic field. That unit is Henry. So what are these key components? We discussed about this in topic. So first what are the discussion for this topic is, first what is DC circuit, the next what are the fundamentals of DC circuits, and what are the terminologies used in the circuits, and what is the real-time applications of DC circuits. So first we see about what is DC circuit. So what is DC circuit? It is the DC circuit is one where the current flow is only one direction, constant and steady over time. How these components behaves in DC helps us design stable systems that deliver power efficiently and safely. So this is the conductor. So in the conductor, it is the simplest of all, the pathway through which electrons flow freely. Materials like copper and aluminium are great conductors because they have plenty of free electrons in conductor materials. In DC circuits, conductors ideally don't cause voltage drops, they just connect all parts of the circuit. So in this topic, next we see about the resistor. Next we see about the resistor. The component controls the current. It offers opposition to the flow of electrons, and that opposition is what we call resistance measured in ohms. So by choosing the right resistor value, so that can be protect the circuits, divide voltage or limit current, like the speed regulator of electricity. So next we see about the inductor. So inductor, it is a coil of wire that resists changes in current. When current flows, it builds a magnetic field and stores energy in it. So that's why when we suddenly turn off your fan, it does not stop instantly. The inductor properly in its coil tries to keep the current flowing. So in steady state conditions, the ideal inductor behaves a most like a short circuit, but during switching it plays a major role in smoothing and filtering current. So next one is the capacitor. Capacitor is nothing but it is the charging and discharging device. It is the energy tank that stores electric charge between two plates. So it charges when connected to DC source and blocks further current once it's full. That's why we say a capacitor acts as an open circuit in DC steady state. So it is also called as it is a storage device. So capacitors used for energy storage, power conditioning and removing unwanted noise from signals, like by using mobile charger we use the capacitor. So next we see about, this is the empathized chart of the resistor, inductor and capacitors. So what is the inductor, what is resistor and capacitor, what are the components and materials used in this, what is the purpose of resistor, inductor and capacitors, we explain in this diagram. So next we see about what is the DC circuit components, already explained what is the function and what is the unit of, so we define in this section. Next, what are the real-time applications of the DC conductors? So, you ever wondered why a long extension wire gets warm when you plug in an iron box? So, that is the resistance at work. That is the real-world applications. Okay. So, or why your ceiling fan takes a few seconds or reach full speed? That's due to inductance in the motor coil, resistance, the sudden change in current. So, and the filter capacitor inside your chargers moves the DC output after rectifications. These are the main applications, real world applications of the DC circuits elements. And this is the main map of the DC circuits, that is a RLC and current, how Ohm's law incorporated this DC circuits, and power dissipation, series and parallel resistor, charge storage device, and RC time constant, capacitor behaviors and opposition, what are the inductors purpose explained in this mind map. The next one is the curiosity challenge. Why does the long extension wire, already I said. So it is a measure temperaturized using thermistor. So why does the ceiling fan takes few seconds? There is opposing change in the current, that is a resistors act in this Next one is the assessment cues. Then two resistors are the 10 ohm and 20 ohm connected in parallel. What current? That is the answer is 10 ohm. So by using the Ohm's law, we can perform the operation calculation, get the output at 10 ohm. Okay. The next, this is a reference for this DC circuits and elements. So this is not the just in this section we will learn about the understanding these fundamentals. It's the first step toward the designing the efficient electrical and electronic systems. That's why this is the basics elements of the fundamentals of electrical and electronics engineering subjects. So this is the basics of electronics, DC circuits, and what are the resistors, capacitors, inductors, what is the electrical and electronic circuits. This is the basic. So thank you all. See you about the next session. Thank you.